Alright, L'Hopital rule problems. Sometimes L'Hopital rule problems are just really simple. I purposely put some tricky ones on the review since I think that's what where we really need the practice. Alright, so if you're going to use L'Hopital's rule, even though it says it in the directions, we're still going to check to make sure that we're allowed to use it, because that's what you need to do on the AP test. So before I do anything, I need to plug in 1 and see if I get 0 over 0. Okay. The natural log of 1 is 0. 1 minus 1 is 0. Like denominators, 1 minus 1 is 0 over 0. Alright, so we're going to use L'Hopital's rule. So we always state that we're about to use it. Remember not to put an equal sign next to the limit because the answer does not equal 0 over 0. We're just stating that that's what we're going to use. Alright, so let's get started. In order to use L'Hopital's rule, we need it to be a ratio. So we can't do it until we add those fractions together. We need like denominators. So the first fraction is going to need an x minus 1. The second fraction is going to need a natural log x. Alright. So altogether we've got x minus 1 minus the natural log of x all over the natural log of x times x minus 1. Alright, so far so good with that? Alright, let's take the derivative here. I'm going to see if I have enough room. Alright, the derivative of x is 1. The derivative of 1 is 0. The derivative of the natural log of x is 1 over x. The derivative of the natural log. Ooh, we gotta do product rule. Alright, here we go. First times the derivative of the second. The derivative of x minus 1, oh, it's just 1, thank God. Alright, so that's easy. First times the derivative of the second plus the second times the derivative of the first, which is 1 over x. Alright. So, let me erase this. Alright, move this up here. Okay, now we can continue. Alright, can I plug in 1 yet? If I plug in 1 divided by, no, I'm still getting 0 over 0, so we need to manipulate this a little bit. So from here, it looks like it's probably just going to be some algebra. So let's see. Let me rewrite x minus 1 times 1 over x as x minus 1 over x. Alright, let's see, you could take the derivative again, but I don't necessarily want to do that if I don't have to, if it's not an easy derivative. So I think we can work this out. Alright, let's simplify the numerator and denominator separately real quick. Alright, so I'm going to do the numerator. Need like denominators. Alright, that's going to give me x minus 1 over x. Alright, so that's what I've got on top. Alright. Oops. I need an x there, to make like denominators. Alright, so that's going to give me x ln x plus x minus 1. Alright, so x times the natural log of x plus x minus 1 all over x. Alright, and that's going to be my denominator. You with me? Alright. So let me come back up here. Alright, that's my numerator. Oops. That's my denominator. And since we're dividing, we're going to do keep, change, flip. So let me keep the top the same, change to multiplication, and flip the bottom. Alright, this is looking good for me because I've got x's that cancel out. That usually means that we're headed in the right direction and we should be able to plug in our limit. So I'm going to rewrite my limit now. Plus x minus 1. Alright, let's see. If I plug in 1, I still get 0 on top. No, I'm still getting 0 over 0. Let's see. Can I factor anything out? No. Do I need to take the derivative again? Looks like it. Man. Alright. Let me leave that for a second. Alright, let's do L'Hopital's rule again. Told you I gave you some tough ones. Alright, here we go. The derivative of x is 1. Alright, first times the derivative of the second plus the second times the derivative of the first, which is just 1. The derivative of x is 1, and so we are here. Alright, x times 1 over x is 1. Alright, I think we're going to be ready now. Let's try it. One plus the natural log of x plus 1. Alright. Equals. Alright, what is the natural log of 1? It's 0, so I've got 1 plus 0 plus 1.